Question 4 in the assess of chapter 17 is a very complicated affair, so I thought I'd cut and paste the question. It says a designer was asked to include an arch of a particular shape in his plans for a building. Now the equation he was given for the arch was y equals 4.5 minus half of an x squared. So in other words, his graph would definitely look a little bit like that, and so would the arch. Alright, so imagine that is an arch into maybe a lounge or something like that. So that's the brickwork, for example. And just rub that out of the way. I'm just going to give you some sort of context that if the guy is asked to build a particular arch according to a certain specification, then that equation is the specification. That's the curviness or the curvature of this archway. Alright? This quadratic equation is symmetrical about the y-axis. In other words, the line x equals 0. If it's symmetrical, they've told us this for a reason. Alright? So we've got something that's going to look a little bit like that. There's the y, there's the x. And it's going to go whoosh, hit the maximum point and come down. Alright? So they've told me to draw the graph from -3 to 3, so I know I'm going to have values from -3 there to +3 there. Now they've given me from 0 to 3 only, so what I do is when I get these results underneath here, I'm going to double up, and whatever I get for 3 I'm going to give to -3, whatever I get for 2 I'm going to give it to the -2, etc. Alright, so I'm going to double up my number of points because I'm told it's totally symmetrical. And incidentally, if you've been following the topic closely, then the maximum value would be that 4.5 there. That is the coordinate 0, 4.5. It won't be bigger than that. That is the maximum point of the graph. Okay, doesn't ask me to find the maximum, but there we go, that's just revision for us. Now, I don't like using these tables at all. I will on this occasion, but I don't like it because I'd rather just work across the page. So all of these are 4.5s because what we can do is take away 0.5 times x squared from the 4.5. So let's just write these 4.5s in and we'll go with their flow. Alright, so here I go. Next thing I want to do is work out minus 0.5 of x squared. Well, I'll use my machine. So 1 squared is 1 times 0.5. Well, that's going to be minus 0.5. So minus 0.5 goes there. And then I can do the takeaway bit. So 4.5 take away 0.5 x squared will be that minus that, which will give me 4 point nothing exactly. Alright. And this one I do the same. I'm going to go 1.5 squared, which is that, and then I'm going to divide by 2, that's what halving means, and I end up with minus 1.125. so that, take away that, we're now going to get our answer. It's going to be 2.875. Now we're going to work with 2, they've already done it for us. 4.5 take away 2 is going to be 2.5. So what we're doing, we're coming down, we're going down, we're going down, right, of course we are. And that's take away that, of course, is 0. Right then, so I've got all these points to plot, so, I mean, most of it's been done for us anyway. So now I want to do a table to include all my minus values. So here I go. X, I'm going to go -3, minus 2.5, minus 2, minus 1.5, minus 1, and minus 0.5, just to get my values there. And my y values will be, starting with the 3, I've got 0 there, and my 2.5, I need to use that value there, so that'll be 1.375. I use my 2, get 2.5, bring it down here. Like I said, I'm just doing a mirror image in each side here, therefore whatever the value is for 3 will also work for -3, so I'm taking them straight from the table. Next one for 1, for 1.5 it's going to be 2.875. These are going to be very difficult to plot, not worried though. And for 0.5 will be the same as minus 0.5, so 4.375. I've now got to plot these little mothers ever so carefully. So let's just turn over the page. So minus 3 to 3. I'm peaking at 4.5. Let's do it as large as possible and see what we can do. Right. Again, I don't care if I don't use all this. What's the peak? 4.5. That's it. Okay. So I'm going to call that 5. 4.5. 4. See what I'm doing? I'm coming back down here in order to get just the right size and not overshoot anything. 1, so it'll be 0.5 and 0, so let's just go -1, minus 0.5 for completeness. Not that I'm going to use that. -1, there it is. So I'm going to go from 0 to 3 in both directions. Let's make it nice and big, and I'm going to go 0.5, 1, 1.5, 2, 2.5, and there's my 3 in the x direction, and this is my y-axis. Of course, I want to go negative as well. -0.5, -1, -1.5, -2, -2.5, and -3 should be just there. I'll extend the line a bit, like so. -3, and that should contain all my points. Now I've got to try and estimate where these are going to go. These are not all easy. So -3, 0 then. Okay, let's just do that. Let's work in red. -3, 0 is there, and I know I've got 3, 0 that works, so I may as well put it in there now. I've got -2.5. I've got 1.375. Well, I'll have a go. 1.3. Well, that's 1 point. That's 1.25, 1.3. I'm going to call it 1.4. Therefore, I'm going to plant it right there. That's what I'm going to do. 1.5, 1.25, 1.3. 2 squares down from 1.5 is 1.4. So I'm going to plant that right there as well. Next one. 2.5. Okay, so it's -2 and 2.5. 2.5 isn't too difficult because it's exactly on the line where I can see it carefully. So -2 will be 2.5. So you can go right there and be happy. Next one. -1.5 and 2.875. Lovely. 2.875. Well, that's 3. 2.8 is going to be 2.5, 2.75, 2.8, 2.875. I'll call that 2.9. So that's 2 squares down from the 3. That's there. And what about you? I'll call that 2.9. So it's going to be there for you as well. Alright, our curve is beginning to form, and I'm plotting as accurately as I can. Next one. Oh, 1 is 4. Alright then. 1 is 4. There's something not right here. The curve's not right. I'm going to go for 1 is 4 and 1 is 4, and we'll try and self-correct in a minute. And 0 is, of course, 0.45. So I think that point and that point is out of order. I'm now going to self-correct that one. So let's just work this out again. Picking up my calculator, I'm going 1.5 times 1.5. That's 1.5 squared. I now want to divide that by 2, because that's what halving means. Divided by 2 is 1.125, and it's negative, so I want to go 4.5 take away 1.125. Do it again. So take away from 4.5. Oh, it's wrong. That should be minus That should be 3.375. Let's just get rid of this. It's wrong, isn't it? Don't know what I did wrong originally. So it's 3.375. Right, so that one's also going to be 3.375 in black. 3.375. That's 4.0. So let's just correct these then. See, this is good, because what happens is it felt wrong, it looked wrong, it wasn't in keeping with the shape of the curve. That should be brilliant. Right, I'm aiming for minus 1.5 and 3.375. So minus 1.5, 3.375. So 3.35, 3.75. What do I want now? I forgot what it was actually. 3.3. So I'm going to go for 3.4. So I can't do it any other way really. So 3.4. That's 3.5. 3.4 will be 2 squares away, which is there. Oh, that should be red. Lovely. 3.4, I agreed with myself. So 3.4 is there, and this one too will be 3.5. 2 squares away will be 3.4, and now I'm really happy with that curve. Just get rid of that little thing there. Right, let's draw it in blue, and I assume it says draw it. Yeah. Draw the graph. This will show you the whole arch. From the graph, estimate. Well, let's just draw the graph first. So to the top we go. Oh, come on, I'll let go. Maximum point. I missed one, but never mind. And there it is. That is the graph of, put it here out of the way, y equals 4.5 minus a half x squared. So how does that compare with what I thought we were going to get? Yeah, well, it sort of goes like that. Right, from the graph, estimate the value of y when x equals 1.2. Okay, x equals 1.2. Let's use my straight line facility, and we'll work in red, I think. 1.2, well that's 1. 1.2 will be 4 squares. So I'm going to plant it about there. Yeah, and then turn left. That's going to be about there on my graph. So this is what my brain did. I went up and left. So that's going to be 3.5. It's 4 squares away from 4, so that's going to be, I'm making that about 3.8. Yeah, it's quite a 3.8. So I'm going to say when x equals, what was it? 1.2, y equals 3.8. So rough check on that one. Yeah, they make it 3.8 as well. So again, my curve was okay, it sort of worked. Next one, find the values, plural, of x for which y equals 4. So now I'm drawing the line y equals 4. Let's do it in green. Want it to stand out. So let's draw the line straight across. Oh, that's not very clear, is it? I want a colour that's not... What should we use? I tend to go for these orangey affairs. Right. Put it straight across the graph there, cut it and label it. That is the graph of y equals 4. Now I want to read down and get my two values there and there. So here we go, let's try and do that. I should go back to orange really to be consistent. Let's just try that one again. Right, that. So I've hit you right there, you come down. I'm going to read you in a minute when I can. So you stop there. You've sort of hit there, haven't you? You come down, straight down here, and it's not perfect. Stop there. Okay. Show the examiner what the brain did. The brain did that, and the brain did that. Let's get the two answers. I'm going to write them right here. So I've got x equals minus 1.1, I think, for that side, and here I've got x equals, well, it should be symmetrical, let's be honest. So that's minus 1.1, that should be x equals 1.1, alright? So again, it's not perfect. What do they make it? Yeah, they call it minus 1 and 1. Right, well, from my curve, I make it minus 1.1 there, and 1 there. If it was brilliantly done and this little blue part of the curve was a little lower, it would have been more to the left, it would have been fine. But that's what I've got. That's the best I can do with the software that I've got. So that is Assess 17 sorted. Okay, so I'll stop the video there.